Welcome to Maths Minders Academy. If this is your first time joining our channel and you are yet to subscribe, smash the subscribe button, hit the notification bell icon so you won't miss out on any of our tutorial videos. Like, share, and comment your thoughts on this video. Guys, today we are going to learn about the frustum of a cone. In one of our previous videos, we discussed the basic properties of a cone as a pyramid, and we are able to see the plane shapes that we are used to build a cone. So today, we are going to move further by looking at what we call the frustum of a cone. If you look at your screen, you will see a complete cone. What do we call the frustum of a cone? We obtain the frustum when we slice off the upper part of the cone. What is left is called the frustum of the cone. So look at what we have on our screen. We have removed the upper part of this cone and we are left with a shape that looks like an inverted bucket. This shape that we are seeing right now on our screen is what we refer to as the frustum of a cone. So in today's video, today's tutorial class, we are going to explore the unique way of finding the volume of this bucket-like object, this frustum. So let's go back to our complete cone. So we have this cone complete, but we are looking at the volume of the frustum. What we need to do is to bring out the height of this big cone. We are going to bring out the height. We're going to look at the radius, and we are going to look at the height also of the frustum. And then we will find the volume. And the method of finding volume requires subtraction. So what is the prerequisite knowledge? You need to understand similarity of triangles. We are going to look at all of this and we'll see how they play together to produce the volume of the required frustum, which is the blue colored part of this entire cone. Let us look at a problem. Here we are told that a frustum of a cone has a larger radius r, which is 8 centimeters, and a smaller radius of r equals 4 centimeters. The height of the frustum edge is equals to 9 centimeters. Calculate the volume of the frustum. So how do we achieve that? Here we put down all the necessary items. We can see the height of the big cone. So we have this as the height of the big cone. Let's mark that. So the height of the big cone is from here this is where we have from here down to this. That's where we have the height of the big cone. All right. And the height of the frustum is from here down. This is the height of the frustum. And we are told that the height of the frustum is 8 centimeters. we do not know the height of the smaller cone, but we know the radius of the smaller cone to be 4 centimeters, and the radius of the larger the base radius of the cone, or the radius of the bigger cone, because here we have 2 cones. We have the smaller, that is the topmost, and then we have the bigger cone. So the bigger circle is the base of the big cone. And we are told that the radius of this base is 8 centimeters, okay? So here we do not know what the height of the small cone is. And then, okay, we are told that a frustum of heights, okay, the radius is 8, so let's remove this. The height of the frustum is given. The height of the frustum here is given as 9 centimeters. Look at it here. They say the height of the frustum is 9, so this is 9. All right. So here we do not know the height of the big cone. All right. And we also do not know the height of the small cone, right? We do not know this. So the height of the small cone is going to be the height of the big cone minus the height of the frustum. So now we are going to use similarity of triangles. So we bring out what we have here. Okay, this is 4. This is 8. This is edge minus 9. And the whole of this is edge. Okay, so here we're going to do, we are going to do the height of the big triangle over the base radius equals the height of the small triangle here, which is edge minus 9 over the base radius, which is 4. So we cross multiply. We have 4h equals 8 into h minus 9. Okay. So now from here, we are going to have 4h equals, we open the bracket. That gives us 8h minus 8 times 9 is 72. Okay, so here we have 4h minus 8h equals to minus 72. This is minus 4h equals to minus 72. And this will give us h to be minus 72 over minus 4 will give us 18 centimeters. So this is the height of the big cone. And the height of the small cone is going to be 18 minus 9, which is 9 centimeters. So now the height of the small cone here is going to be 18 minus 9. And this is going to leave us with 9 centimeters. So let's get volume of frustum of a cone is going to give us 1/3 pi. All right. Now let's take radius, the radius of the big cone is 8 squared times the height, 18, minus 1 over 3 pi. Okay, let's look at radius of the small cone is 4, then squared times the height is 9. Okay, let's return our 1 over 3 pi. Okay, so here we have 64 times 18, and that will give us, if we look at it, 1,152. So we have here 1,152, and of course, this, what do we have here? This is 16 times 9. We have 144 here. Okay, so if we subtract 1 over 3 pi, okay, we have 1152 minus 144 here. Okay, let's block out this. Okay, this is going to give us, if we look at this, in terms of pi, this is going to give us 336 pi. Of course, if we substitute 22 over 7 for pi, this is going to give us 1,056 cubic centimeters. 1,056 cubic centimeters. Guys, that will be the volume of the frustum of this cone, whose dimensions are given in this problem below. So the volume will be 1,056 cubic centimeters.
Do you recall what do we call the frustum of a cone? We say the frustum of a cone is the object that we obtain when a plane slices horizontally through the upper part of a cone in such a way that what is left at the upper part is a circle, a small circle, smaller than the circular base of the entire cone. When that happens, we obtain what is referred to as a frustum. And this frustum of a cone looks exactly like the inverted bucket, a bucket that is turned over. That is frustum of a cone. Do you also remember what we said about finding the volume of this frustum? For us to find the volume of the frustum, we are going to look at the entire picture. We are going to see the entire cone. So we are going to bring up the cone as it were, and we are going to look at both the height of the big cone and the height of the small cone. We are also going to look at the radius of the big cone and the radius of the small cone. So for us to obtain the volume of the frustum, we are going to do volume of big cone minus the volume of the small cone. What we have left will be the volume of the frustum.
I hope you've learned something in today's video. If you are new and you find value in our tutorial video and you are yet to subscribe, why not smash the subscribe button, hit the bell notification icon, go to the comment section and tell us what you feel about this video. We urge you to be with us in our next tutorial class, where we will be exploring the frustum of another pyramid. We'll be looking forward to having you in our next class. This is Math Minders Academy saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught